In this class, we're going to proceed with the calculation on the basic machine that we discussed in our previous class. We have done two of these basic machines. These include the lever and the pulley system. Now we're going to have questions on wheel and axle, you understand? Okay, so please, I want you to pen this down. A mass of 35 kilograms is to be lifted up by a wheel and axle system. The radius of wheel to the radius of axle is 5:1. Given that the system is 84% efficient, determine the effort required to lift the body, taking G equals to 10 meters per second squared. Okay, please, I want you to pay attention. Let's start by writing out the information that we're given in the question. We are given that the mass of the load, let me just put it like that. The mass is what? Mass is 35 kilograms, you understand? And we are given that the ratio of the wheel to the radius of the axle is 5:1. Please pay attention. You know that this is how wheel and axle look like. We have the wheel, which is attached to the axle, you understand? This is it. This is the diagram. I'm just trying to draw the diagram now, okay? Then we have the load, you understand? And we have the axle here. Okay, you know, this is how the wheel and axle look like. The wheel has a radius. I've discussed, we've learned this in our previous class. Also, the axle, which is the arm, that one that looks like a rod, also has a radius, you understand? So the question now says that the ratio of the wheel to the radius of the axle is 5:1, you understand? So that means that, let us represent the radius of this wheel, let us represent it as big R, you understand? The big R, okay, let me just put it, ratio now is what? Ratio of the wheel to axle is 5:1. 5:1. Now, the radius of the wheel, play attention. The radius of the wheel, that is 5. You understand? Because when we talk about the ratio is in order. If I say that the ratio of boys to girls in the class is 2:1, that means that the ratio across the boy, when there are two boys in the class, there is a single girl, you understand? So that is it. Ratio tells us, it gives similarity between two quantities. So now we are talking about the ratio of the wheel to the axle is 5:1. So this 5 belongs to the wheel, you understand? And this, the radius of the axle now, equals to 1. Okay, equals to 1, you understand? This one belongs to the axle, you understand? Because the wheel comes first and then the axle came second, you understand? So that is it. Now, given that the system is 84% efficient, that means that the efficiency of this wheel and axle system is what? 84%. Efficiency equals to 84%. Now, we are asked to determine the effort required to lift the body, okay? The effort required. We don't know the effort. We have to determine it. So I'm going to represent it as question mark. Now, we are given that G, which is the acceleration due to gravity, is what? Meter per second squared. Okay? Now, these are the information that we are given in the question. We want to determine the effort. Now, what is the formula are we going to, which formula, with respect to this parameter that we are given, which formula are we going to use to determine the effort? Don't forget that mechanical advantage is equal to what? Load over effort. Okay? Mechanical advantage. Let me erase this, okay? Let us erase this. Since we are done with this, let us erase it. Mechanical advantage. I'm still on this question, okay? Mechanical advantage equals to load all over effort. You understand? Now, I don't know the mechanical advantage. If I know the mechanical advantage, I can easily determine the effort because I've been given the load. All I have to do is that I just have to convert 35 kilograms to Newton. You understand? But I don't even know the mechanical advantage. So how do I go about this question? Okay, x is equals to 350 divided by 0.168. That will give us 2083.33. You understand? Because the decimal point is a recurring decimal point. So let us leave it at 2 decimal places. You understand? So the value of the effort that is required to lift the load is 2000. Oh God. Just pay attention, okay? Now, I'm going to give you a formula now. The formula is for efficiency. Efficiency equals to mechanical advantage all over velocity ratio. You understand? Do you know that the parameter that I'm given in the question is what I'm using? I'm just trying to take advantage of the parameters that I'm given in the question to know how to determine the effort required to lift up the load. You understand? So that's what I'm doing. I'm giving the efficiency in the question, and I know that efficiency is given by the mechanical advantage all over velocity ratio. Now, if I know velocity ratio, I can easily determine the mechanical advantage. Then, having determined the mechanical advantage, I can determine the effort. You understand? So velocity ratio for wheel and axle system now, the velocity ratio is equals to, please, there are two important things that I want you to note. Here, there are two important things that I want you to note. You know that wheel and axle system, this is the load, okay? This is the load. The load is what? 35 kilogram. The load is 35 kilogram. This is the wheel. You understand? This is the wheel and this is the axle. This is the wheel and this is the axle. This is the load. You understand? Now, the velocity ratio of a wheel and axle system depends on where the load is. You understand? Please pay attention. I'm going to repeat that. The velocity ratio of wheel and axle system depend on where the load is. Are you paying attention? If the load is on the wheel, you can see that the mass is on the wheel now. This is the wheel. The mass is on the wheel. If the mass is on the wheel, the velocity ratio will be the ratio of the axle all over radius of the axle all over radius of the wheel. You understand? Listen to the explanation again. If the load is on the wheel, as we have in this question, the velocity ratio is equals to the radius of the axle all over the radius of the wheel. That means velocity ratio in this case will be the radius of the axle all over the radius of the wheel. You understand? Because the radius of the axle is what? Is small r. Okay? And let me represent as small r. Radius of the axle, and the radius of the wheel is big R. You understand? So in this case, the velocity ratio here is 1 over 5, because the radius of the axle is what? 1, and the radius of the wheel is what? 5. So 1 divided by 5 is 0.2. You understand? So the velocity ratio here is what? 0.2. Do you understand? Okay? Now let's assume that this is just an assumption. Okay? Let's assume that the load is on the wheel now. The load is not on the axle. The load is on the wheel. The velocity ratio will be the radius of the wheel all over the radius of the axle. You understand? In this case, I'm going to have something like this. The velocity ratio is equals to R all over R. You understand? Because the load is not on the axle. If the load is on the wheel, then the velocity ratio will be the radius of the axle all over the radius of the wheel. If the load is on the axle, the velocity ratio will be the radius of the radius of the wheel all over the radius of the axle. You understand? So you have to be able to differentiate it. Okay? If the load is on the wheel, the velocity ratio is the radius of the axle all over the radius of the wheel. If the load is on the axle, the velocity ratio is equal to the radius of the wheel all over the radius of the axle. You understand? So this one is radius of the axle all over the radius of the wheel. This one is radius of the wheel all over the radius of the axle. You understand? Please take note of that, because you might be given a question in exam that says assuming, after giving you the question like this, take G equals to 10 meters per second square, assuming the load is on the wheel. What is the effort required to lift up the load? You can see now. So pay attention to those two concepts, okay? And never forget. Now, so having determined the velocity ratio as 0.2, so I can easily get the mechanical advantage. You understand? To get the mechanical advantage, all I have to do is that I'm going to substitute efficiency and velocity ratio as 0.2, and efficiency as what? 84%, and velocity ratio as what? 0.2%. By so doing, I'm going to get the mechanical advantage, okay? So let's go. For this, I'm going to have, efficiency is what? 84%. So I'm going to have 84% equals to mechanical advantage. Mechanical advantage is unknown, so I don't know it. That's what I want to determine. All over the velocity ratio. The velocity ratio is 0.2. This over 0.2. You understand? 84% is also the same thing as 84 over 100. Okay? 84 over 100 equals to mechanical advantage all over 0.2. Okay? Take the cross product. I'm going to have mechanical advantage multiplied by 100 equals to 84 multiplied by 0.2. You understand? For this, I'm going to have mechanical advantage equals to 84 multiplied by 0.2 all over 100. You understand? 84 multiplied by 0.2, that will be 0.168. So 84 multiplied by 0.2, that will be mechanical advantage equals to 16.8. So all over 100. That is, I'm going to have mechanical advantage equals to 16.8 divided by 100. That will be 0.168. You understand? So for this, I'm going to have 0.168. Now, having known that the mechanical advantage is equals to 0.168, I can easily calculate the effort. You understand? You know, the relationship between mechanical advantage and effort is that mechanical advantage is equals to load over effort. And the load that we are given in the question is 35 kilogram. You understand? So mechanical advantage, pay attention, equals to load over effort. Load over effort. Okay? And load equals to 35 kilogram. 35 kilogram. Now the load in Newton, let us convert it to Newton, equals to what? 35 multiplied by 10. That will be what? 350 Newton. Do you understand? I cannot use the load as in kilogram. You understand? I have to convert it to Newton. So in order to convert 35 kilogram to Newton, I multiply it by what? 10. So I have 350 Newton. So the mechanical advantage is what? 0.168. So I'm going to have 0.168 equals to load, which is 350 Newton, all over the effort. The effort is what? Effort is what I want to determine. So we don't know the effort. You understand? Please, do you understand what I'm doing? All I'm doing is that, you know, the relationship between mechanical advantage, load, and effort is what? Mechanical advantage equals to load over effort. You understand? No, I know the value of mechanical advantage, which is what? 0.168. The load is 35 kilogram. 35 kilogram in Newton is what? 350 Newton. So in order to determine the effort, I substitute all the parameters that I have in this formula. So if I take the cross product, I'm going to get the effort. Let us represent the effort as x. Okay? Let us represent as x. So x multiplied by 0.168 equals to 350. You understand? Divide both sides by 0.168. 0.168. This over 0.168. So x equals to 350 divided by 0.168. That will give us 2083.33. You understand? Because the decimal point is a recurring decimal point. So let us leave it at 2 decimal places. You understand? So the effort required to lift up the load is 2083.33 Newton. You understand? You know, effort is also like a force. You understand? So the effort required to lift up the load is 2083.33 Newton. Do you understand? So that is the solution to that question. So we have done question on lever, we have done question on pulley system, we have done question on wheel and axle system. Now let's move to the fourth basic machine that we discussed, that is the inclined plane. To watch the next class,
kindly check the description of this video. You are going to see a link there. Click on that link, or you should check the playlist on this channel. Okay, see you in the next class.